So logs are the inverse functions of exponentials and powers, a bit like how multiplication is the inverse of division. They're also useful for looking at larger range of numbers easily, and also for mathematical modelling, for example, of population growth. Today we'll just be discussing this first point in detail. So here's a general log expression. We actually need a full equation for this to actually make sense. So we would read this as 3 raised to the power of x equals 9. This is actually equivalent to the mathematical equation shown here. And we know that the answer is 2 because 3 squared equals 9. So the full log equation will look like this. So we have shown that we can have a general relationship between a power and the log form of an equation. So the second type of problem we're going to look at is dealing with fractions in logs. So the first way is more of a direct method where we'll use the general approach seen before, but then we'll go straight to the answer where we know that 2 to the power of minus 3 is equal to 1/8, or where x is equal to minus 3, or we can use an indirect approach where we're unsure of this middle step, where we use the same general approach and change it to the power form, but then we will massage the right hand side more to make it something more easy to work with. So we know that 8 is actually equal to 2 to the power of 3. Then we can flip that fraction such that we times the power of the bottom number by minus 1. So here we also see that x is equal to minus 3. So we have come up with a second relationship here where the fraction inside the log can be flipped, or the power of that whole fraction can be times by minus 1 if we just take the minus of that log of the whole expression. So now we're going to look at the domain and range of the log function. So we see that the input for the log, if it is a positive number above 1, then we will get a positive number of 0 as an output. But if we have a number between 0 and 1, we will actually get a negative output from the log function. So what happens if we have a number such as 1? So if we have log of 1, that actually means that we are taking the log of base 10 of 1 and seeing if there's a number x such that we have 10 to the power of x equal to 1, is there such an x that exists or makes sense? And there is. That's basic power law where x is equal to 0, and this is true. So log of 1 equals 0. What happens if we take the log of 0? Once again, we see that there is the expression 10x is equal to 0, 10 to the power of x. But there is no x such that this makes sense, so we say this region is undefined. If we try and take the log of a negative number, we will see that there is also, again, no x for this that makes sense. So there are 3 facts that we have found out about logs today. So we see that there are interchangeable expressions or equations for log and powers. We see that if we flip the fraction inside the log, then all we have to do is times the whole expression by minus 1, and that the domain of the logarithmic function is of positive numbers, and that for below 0 it is undefined. Cool. That is it for today. Thank you for listening.